welcome again to a new video. And this time, this topic is going to be very different. We are going to talk about the offshore structures. In civil engineering, generally, we make offshore structures very far away from the shores, and we generally use it for many different purposes, like for the oil, for the electricity, and for many different things. In this short lecture talk, we are going to see that is what is the concept of this offshore structure, what are its types, and we are going to think about that is what are the design considerations while you can say constructing this type of structures. So I'm Jitendra Chaubisa from Civil for Shore Academy. Let's start our video. So first of all, we are going to talk about that is what are the offshore structure, the basic definition of the offshore structures. After that, what is the necessity of constructing this type of structures? After that, we'll talk about the types. We have broadly very much of the types right now here in the offshore platforms. Then we are going to talk about the design consideration. What are the factors that we need to consider while designing this type of structures? At last, I will give you some resources to get start your career if you want to make your career in the offshore structures. Okay, so let's start. First of all, we'll start with the basic that what are offshore structures. See, these are the installation, or you can say these are the kind of structure or facilities which are made in the marine environment far away from the coastal area into the deep sea waters, and they are usually made up of to produce the, or you can say to produce and to transmit the electricity, or you can say for the oil, for the gas and other natural resources, we make offshore structures. These structures are usually far away from the coastal areas. They are into the deep areas. They can be into the shallow areas also, but it totally depends on the, you can say, the reserves. Where are the oil reserves? When we talk about the oil reserves, or you can say the crude oil reserve, we usually talk about UAE, or you can say we talk about the USA. It means they have a very high, you can say, the crude oil reserves trapped in between the rocks somewhere down the crust. Okay, so we need something. We need to drill it. Okay, it can be on the ground. It can be far away into the seabed also. So in case of sea, or you can say the ocean, we usually need a structure, stable structure, which is going to be placed firmly at the some specific location of sea, and then we are going to drill there and we are going to transport the oil after processing and all. Okay, so oil platforms are the best example of offshore structures. See, offshore structure are in broad term doesn't always signify the oil rigging. It can be about the something you can say about the marine study also. If you want to study some kind of specific species, then we need some kind of platform far away in the ocean where we can study all this. It's not always necessary that offshore structure means the oil rigging. Okay, it can be anything else also. It can be according to the research purpose also and so on. But in a majority scale, we can say that the offshore structure are always going to be the oil rigging one. Okay, so oil platforms are the major example which are used to drill, and they are the production activities which are going to be carried out that particular place. These rigs can be floating vessels or they can be jackup designs. Okay, we'll talk about these type of designs later on in this lecture talk. So let's clear at this moment that offshore structure are offshore. Okay, they are not on the shore, they are far away. You can see an image onto the right hand side of your screen that these kind of structure are known as offshore. Okay, people are going to live there, they are going to rig there, they are going to work there. So everything is going to be there. Okay, so let's move ahead. Now the question arises, what is the necessity? Is it necessary enough? Yes, the necessity lies in the demand of oil. That is our crude oil we are going to talk about here. Crude oil, as you all know, it is a very essential for our day-to-day life. We use it in transportation fuel. First of all, our car, bike, buses, even jet fuels. The fuel is going to be used in the aeroplanes is going to be the crude oil. We are going to separate things from crude oil like diesel, petrol. These all things get separated out at different, you can say, temperature by the fractional distillation process. So the transportation fuels is going to be there. Heating oils that we use to heat up our room and all those things. So where at that particular point, oil is going to be useful. Electricity generation. Some of the electric generation plant uses oils to heat up the water, and then after all the steam process is going to be there. So electricity generation, the manufacturing process, in manufacturing process, the oil is going to be used. Okay, medicine, pharmaceuticals, personal care products, we use oil. So oil has a major demand and it is going to be there. Okay, so because of oil, we need to make offshore platform. So this is going to be our necessity. So now we know what is the basic meaning of the offshore platforms. Now I'm going to use the word platforms. The moment I'm going to use the platform word, that means we are going to talk about the rigging process. That is, we are signifying that as the oil process, oil rigging process. So offshore platforms means the one structure which are made far away from the offshore and they are in the deep waters. These are the kind of a structure that can be RCC and steel structure. Okay, can be RCC plus steel structure, and they are going to be made to produce the oil out from there, that particular position. Okay, and we also know the necessity. Oil is in a very huge demand, so we need to do it. Okay, now let's go a step beyond and try to see some technicality of the offshore platform. The offshore platforms has different types. You can see it here. The first one is that is substructure. Substructure means the one which is below the sea level. Okay, it is going to have a fixed platform. It can be floating platform. Okay, it is going to provide the support and stability. The second one is deck. Deck is the one which is onto the top and side, where all the facility, machinery, equipment is going to be there. Okay, drilling equipment is there. The central size will be the drilling equipment. Okay, it is going to extract the oil and gas from beneath the seabed. There are going to be production facilities. Okay, reservoir is going to be there. All the other facilities are going to be there, which is going to produce that particular crude oil. There are going to be riser and pipelines. See what happens. The crude oil is generally tapped into between these. You can say the rock surface is in very high. You can say pressure. So generally, what happens when we are going to punch in between these rock, the oil is going to flow automatically upward if it is going to have that much of pressure. But if it doesn't have that much of pressure to flow up, then we are going to use some kind of a specific kind of pumps and machines to get it up. Okay, so these riser and pipelines are that part of our platform. Mooring and anchoring systems are the one which are going to anchor our structure to the seabed. The platforms are going to be of different type. We are going to see into the next slide that these can be the fixed and floating. So in case of floating, it need to be fixed by some anchors. Okay, so they are going to be the tethers, or you can say some kind of a tendons which are going to fix this platform up to the seabed. Okay, we are going to do it like that. So these are the basic main parts. You can also see the diagram. There is a flare boom onto the top. There's going to be a communication tower onto the top. We're going to have a helideck also, okay, for the faster communication, and the other things are also there. Let's move forward and let's move one step forward and let's see what are the types of the offshore platform. The first type is known as fixed platform, and the second type is known as floating platform. First, we are going to talk about the fixed platform. In fixed platform, we have another three types, that is jackets, gravity-based structures, and compliant towers. Into the floating, we have floating production, storage, and offloading, that is FPSO. And floating production systems are there, tension lag platforms are there, spar platforms are there, and semi-submersible platforms are there. Okay, the first we'll talk about fixed platform. Now, as the name suggests, fixed platforms, which are these are going to be the one which are going to be the permanently attached to the seabed, and they provide a stable base for the oil and gas exploration. They are going to be fixed, okay, connected to the base. The first type is the jacket type. The jacket platforms are the one which have a steel frames with legs that are anchored to the seabed using pile structure. You can see onto the right hand side of the diagram that there are going to be pile structures onto the bottom, and steel, you can say, frame with leg type of structure is going to be attached to them. So it is going to be totally a fixed structure, and it is going to provide, you can say, a very good stability, or you can say reliability of the structure. Okay, so it's kind of a very simple to understand. One thing to note here that this type of structure is going to be used in shallow areas, okay, not going to be into the deep areas. Second one is gravity-based structure, GBS. You can see here that GBS platforms are large concrete structures that rest on the seabed. In the right hand side of the diagram, you can see these are the huge concrete columns which are going to be there, and because of their own weight, they are going to resist the forces of waves and current. And on to our these structure, we are going to have our steel platforms. Okay, so these are commonly used in shallow water depths. Again, we can say that we can't use it for the deep waters, okay, because at that particular point we will be in need of, you can say, a more of concrete there, and a more of research and study about the concrete remaining in that water for so long. Okay, so we need to study that kind of thing also. Third one is the compliant tower. These are the tall and the slender columns, okay, and these are going to design in a such a way that they are going to sway with the motion in the sea. They are going to provide some of the flexibility here. Okay, they component structure take the stiffness also and take flexibility also. They give profit of both the things to us. So component towers are going to be tall and slender portions. Okay, so they can be used to withstand the harsh environment conditions and such as hurricanes and the strong ocean currents. Okay, so now we know what are the fixed platforms. Now let's talk about their advantages and challenges. First of all, if we talk about the advantages, they are going to be stable and reliable, as we know all. These are well suited for shallow to intermediate water depths. Okay, they can support a wide range of production facility. Now, what are the challenges? First challenge is limited to certain depth of water. Okay, we can only use it for the, you can say, the shallow depths. We can't go for the deeper portion of the sea. Okay, installation and maintenance can be complex, vulnerable to the extreme weather conditions and environmental factors. Okay, so these are going to be the advantages and some of the challenges we have. Now let's jump onto the floating platforms. That is our second type of platforms. Floating platforms are the one which are not permanently attached to the seabed. As the name suggests, they are floating. Okay, so if they are floating, how we are going to fix them, or how we are going to handle them, or how we are going to fix them at a particular place? We use anchors or dynamic position system to maintain their position. Okay, so because of that, we can use this type of platform in varying water depths. We can use it in shallow and deep both. First type we are going to talk about is the floating production, storage and offloading vessels, that is FPSS vessels. Onto the right hand side, you can easily see these are kind of oil tankers, or they are purpose built ships which are going to be used for production also, storage and offloading also. Okay, so these are majorly used for oil and gas production. Okay, so these are the floating production and storage offloading vessels. The second one is floating production system. These are same as that of the previous one. This can be semi-submersible. They can be of, you can say, the ship-shaped structure. They're going to be almost same as in the previous one. Third one is the important, that is going to be tension lag platforms, which are in short known as TLPs. These TLPs are tethered to the seabed, or you can say they are tethered with the vertical tendons or the tethers. They are going to be the ropes which are going to be tied onto the bottom of them, and the another end is going to be tied at the seabed. You can see into the picture onto the right hand side that there are going to be the tethers which are going to be tied. What these tethers do, this tether restricts the vertical movement and also restricts the horizontal movement to some extent. Okay, so in that case, it provides flexibility also and stiffness also. So that's a kind of a very good thing about TLPs. So they provide stability by applying tension to the tendons and by allowing the platform to float while minimizing the vertical movement. Okay, so they can be used in deep water. They have a very huge advantage of being used in the deep waters. The fourth one is the spar platforms. Spar platform are deep draft floating structures that consists of cylindrical hull and a moved vertical column. Onto the right hand side diagram, you can see this is going to have a cylindrical hull here, and it is having a moved vertical column. The vertical column is going to be moved by the tethers or the tendons right to the seabed. Okay, this is going to have a heavy weight at the bottom to stabilize its vertical movement. Okay, so these are designed to float vertically and are stabilized by a heavy counterweight onto the bottom. So spar platform are again going to be used for the deep water applications. Okay, so these ones, spar platform and TLPs, are going to use for the you can say the deep sea water. Okay, now let's talk about their advantages and challenges. First of all, the advantages is going to be they are suitable for deep water and ultra deep water. Okay, they provide flexibility, they provide the mobility. In case of, you can say, high current or high wave, they are going to provide flexibility. Can be quickly deployed and relocated as needed. We can relocate them easily because they are not fixed. Okay, now what are the challenges? Higher initial investment is needed. Maintenance and logistic is going to be very much complex. Right? And the vulnerable to harsh weather conditions and ocean current. If the weather is going to be very harsh, then it is going to be somewhat difficult. Research is going to be needed. More of the research is going to be needed for the manufacturing of this particular thing. Okay, so now we have a basic idea of what are offshore structures, what are their necessity, what are their types, fixed and the floating. We have also gone for the TLPs and the spar platform. Now let's talk about the design consideration. What are the considerations that we need to do in order to fix that what kind of offshore platform we need to use at a particular position? First of all, we need to check for the water depth. So if the water depth is more, we are going to be for the TLPs or the spar. Either water depth is less, we are going to go for the GBS or the you can say the jacket ones. Okay, environmental loads are going to be there. We need to check, that is currents, winds, past performance of that particular place. In case of this environmental loads, we need to check it out. Soil conditions need to be seen, because we are going to be into the seabed. So we need the soil conditions, that what kind of a bearing capacity is there, stability influencing the foundation, what kind of the composition of the soil, that we need to check. The next one is structural integrity. That structure is going to be there. Material selection, corrosion protection measures must have to be there, because our structure is going to be into the water for years, and they're going to be the salt spray, there are going to be chemicals also there. So we need to check that what kind of material we are choosing. That material must have to provide structural integrity. Okay, the next one is very important, that is safety and risk management needs to be there, because we are far away from the coastal area. We can't have the emergency, you can say, medical help there. There is an you can say provision of helipad there, that the plane can, the helicopter can come and it can provide assistance, but still we need to have safety and risk management there. That primary fire explosion, if the fire explosion is going to be there, oil spill is going to be there, a personal hazard is going to be there, we must have to have a plan, or we must have to have an infrastructure, so that we can come up of that particular emergency. Okay, so safety system, redundant equipments must have to be there. Okay, operational requirement we need to consider while designing, that is how the space is going to be utilized. If it is going to be multi-story, it is going to be a single story, like that the layout is going to be there. Regulatory compliance must have to be needed. The code checks must have to be done before prior to the designing. Environmental impacts must have to be checked. Okay, as we know, we are going to be drilling at somewhere in between the ocean. We are going to blasting there. We are going to create a major vibrations there. So it's obvious that aquatic life is going to get disturbed. So we must have to check that the environmental impact must have to be reduced. Okay, or it must have to be avoided. The life cycle consideration and the accessibility and logistics must have to be. Okay, so these were the design considerations that an engineer or the planner must have to do prior to the designing and deployment of this type of structure. At last, let's talk about the design considerations, and in that particular case, let's talk about the load consideration. What kind of loads we are going to consider? Environmental loads must have to be there, and by applying the classical wave theory, we can predict the loads. By applying the classical theory, I mean by applying the frequency and the amplitude logic and that sine theta, wave theta, that form we need to use. And the wind load and earthquake load, which are going to be the dynamic into the dynamic effects, we need to use that one also. Ice loads, if there is any impact and non-impact load by the waves, we must have to consider them. Blast resistance must have to be there. Okay, fire resistance must also be there. It is must. Fire is going to be there. Okay, so these are the loads that an engineer generally consider in at the time of construction. Okay, so at last, let's talk about some of the resources. If you find out this topic very interesting and you want to work on this topic a little bit, or you want your career in this topic a little bit, so what you can do, I'm sharing here these two things. That is the free video course. It is by the NPTEL, and it is available freely on the NPTEL and the YouTube also. It is a 12-week course if you are going to do it on NPTEL, and 52 video course if you are going to do it on YouTube. It is totally free. It's free to watch. The link is there. The name of the course is Offshore Structure Under Special Environmental Loads, Including Fire Resistance. I'm assuming that you must have to be a diploma in civil engineering, or you must have to be a bachelor of engineering in infrastructure or civil engineering or environmental engineering, somewhere like that. Okay, I will provide this link in the description. Another thing is the Bentley is having a software for offshore structure, that is the SACS offshore structure. You can apply online through this link for the education license, or if you are a teacher, through the teacher license, you can download it for free. Bentley have a free webinars and free resources available on their site. You can easily watch out from there. So I hope you have learned some new things in here. Okay, so this was the video about offshore structures. We have learned about that what are offshore structure, why we need offshore structure, what are the type of the offshore platforms, what are the design consideration, what are the loads that we consider while designing offshore structure. And I have also shared with you a free resources from where you can start your career in this particular topic. So guys, thank you for listening. I hope you have enjoyed this topic. If you have any question, please comment down, and we'll meet in the next video. Till then, bye-bye. Take care.